All right. Hi, everyone. This is just a supplement to the directions. So if you think you fully understood the directions in the introduction to exponential growth, then you don't have to watch this, but you might find that this is helpful. So you should open a new Desmos blank graph, like I've done here, and then open up the Google Sheet with the data in it from Google Classroom. So I have that open here. And we just want to take our days and our total number of cases. So this is cumulative cases over the last like half a year. So we have a lot of days. So just highlight all of them, click and hold and scroll down until you get to the very end. There's a lot of numbers here, but that's okay. And what I'm going to do is leave it at the last, at day 299, where we actually have a day data. I probably could have put the 300 in there, but that's okay. And now that we've done that, you do a copy. So Control Command, whichever one you're using, C, and then go back over to your blank Desmos graph and just put the cursor in here. And you don't have to set up a table. It'll do that automatically, and we'll paste it. And now the key here is we have our X1 value, which is the days, our Y1 value, which is the cumulative number of cases. And there you can see the because we have so much data, this almost looks like a connected line, but each of these things are individual points. In the next part of the directions, we have looked at linear regressions or linear lines of best fit for things that we think have a linear correlation. Now, this clearly isn't linear. And so what we're getting into is learning about exponential. So to test exponential growth, we're going to use our exponential function. So just type y1 and it automatically does a subscript, squiggly line, and then A, B, and then a little caret to give us an exponent. That was shift 6. And our exponent is going to be our number of days. And so what you can see there is that created a curve. That's my black line here. You might have a different color, and it doesn't fit the data perfectly. But what the questions are going to guide you through are things over here. So here's our formula. We have our R-squared value, which you've learned about from linear regressions. We have our parameters A and B, and that's explained a little bit more in the document. But just if I can zoom in here, now you can tell that it doesn't look anywhere close to the actual, the model doesn't look anywhere close to the actual points down here. But that 109 over here is our starting value, or our y-intercept. And then our b value is our multiplier. And so what we're basically saying is each day there is 1.01428 times as many cases as the day before. Now, if you had 1 times as many cases, it would stay the same, or it'd be a flat line. So the reason it's going up is because we're multiplying it by 1.01, which is something slightly bigger than 1. So it's not going up a lot, but 109 becomes 111 or so. And so you can see that's how it grows. And then because we're multiplying it by the previous number by the same number each time, that's what causes the growth to accelerate. And you can tell that the acceleration or the rate of increase increases. That's a calculus concept you'll learn later. But not only is this increasing, but the rate of increasing, it's getting steeper and steeper. The rate of increase is increasing. So I hope that helps for you to set up your Desmos and to answer some of the questions in the introductory assignment for the day.